Hi again. This time I'd like to present my paper. The title is Increasing Transmission Control Protocol Speed in TCP/IP Networks by Reducing TCP-ACK Collision Probability. This paper is also submitted for the first conference on Internet of Things and Embedded Intelligence held in Yogyakarta on July 29, 2020. Okay, TCP transmission control protocol provides reliable data transmissions and makes sure that every packet sent in the network received successfully by the receiver and sequentially. But the acknowledgement and retransmission within TCP protocol injects additional delay that is not suitable for real-time applications, even though some low bitrate application such as YouTube or other application still use TCP for the packet transmission, but for higher bitrate delay increases significantly. In some cases, the high bitrate application compensate this delay by introducing application buffering. But for some users, buffering is not acceptable. Meanwhile, other protocol, user data graph protocol, or briefly UDP, minimize service delay by using only limited headers and omitting the connection-oriented service such as acknowledgement and retransmission. As a result, UDP produce smaller delay, but this protocol often suffers packet losses, and in some applications, these losses are not acceptable. Yes, there have been many works on TCP and UDP enhancement. Some works edit TCP properties into UDP protocol or adding negative acknowledgement on UDP protocol. Some application combines TCP and UDP, such as in real-time protocol, RTSP, and other streaming protocol. In TCP itself, the enhancements are dominated by the modification of flow control techniques. This results TCP has many variants such as TCP Vegas, Reno, and others. Meanwhile, TCP and cross-layer techniques have also been proposed by many researchers to obtain lower layer support. Some work to manage TCP windows, others to explore the lower layer support to TCP flow. This paper improved TCP by reducing the probability of the collision for the TCP acknowledgements packet. We will present the mathematical analysis for this proposal and implement the proposed method in 802.11.0 network, which is Wi-Fi network, WiMAX, which is 802.16 networks, and also in a large network. The proposed technique is to reduce packets or frames that carrying the TCP acknowledgement. For instance, if we analyze the contending network by using the most common mathematical expression, the probability of the collision is depending on the traffic and also number of nodes. And the mathematical analysis shows that the back-off duration, which determine the delay of the transmission, depending on the lambda, window size, and also number of nodes. Our proposed method is to reduce any frame within lower layer that carrying the TCP acknowledgement packet, so that this packet is prioritized in MAC layer. In the mathematical analysis, we reduce the interframe time by factor of alpha that produce the reciprocal time probability by x per 2, and by substituting these equations into the aforementioned model, we get this kind of graph here, the collision probability graph for the 802.11 networks. The probability of collision for the frame containing TCP acknowledgement reduced by at most 50% for the number of user 10, and quite closer to the initial network for increasing number of nodes. Then we try to implement the proposed method in Wi-Fi network. The strategy is by reducing the DIFS parameters within Wi-Fi network for the frame containing TCP acknowledgement. So here is the experimental network that contains 19 up to 19 nodes. The traffic flow from the access point to mobile nodes. We then modify the algorithm within the access point to implement interframe space, DIFS, distributed interframe space within the access point, which is reduced about 50% for frame containing TCP-ACK. As a result, here you can see that the probability for the TCP-ACK reduced significantly and almost consistently for all number of nodes. Of course, we use the NS2 simulation here, which is a discrete event simulator, not mathematical based simulation. So the graph is not really smooth. But in overall, the delay of the proposed algorithm, the proposed method, is lower than the initial state. We change the distributed interframe space for the 8 frames from 10 to 15 microsecond, which produce a consistent lower delay for the overall package. Here the jitter value is not really matter because the value is in order of millisecond here. So even the value flip uh, in some points, yeah, but this jitter is still acceptable. Next, we implement the proposed method for the WiMAX network. Here we have point-to-point connections, which is the subscriber station receiving data from the server, which is connected by using Ethernet network to base station. So the every data flow to subscriber station should be acknowledged by subscriber station by using TCP-ACK. So server should receive TCP-ACK before sending the next data. So the faster the TCP-ACK arrive into the server, the faster the next data is sent to subscriber station. So in order to allow TCP-ACK transmit faster, we modified the MAC layer of the base station here. We in the reassembler frame, the incoming packet will be checked either the frame containing the acknowledgement byte or not. If the acknowledgement byte, which is flagged by a sign in the frame, yeah, if it is identified, then earlier bandwidth request will be made so that the next TCP-ACK will be prioritized. So TCP-ACK will get bandwidth earlier than the others, so that the TCP-ACK flow faster. By running the traffic by using the multimedia traffic taken from existing source, we get here the delay of the proposed method consistently decrease is lower than the existing techniques. We implement here by using the round robin scheduler and best effort quality of service. So by changing the frame rate of the video traffic from 0.3 to about 10 frames per second, we got consistent lower delay for traffic flow. Next is by implementing the proposed techniques into the large network. Here we have two computers connecting one another. PCA connect to PCB through the complicated networks. So PCA send data and PCB send TCP acknowledgement to indicate that the PCB has received the transmitted data. So in order to fasten TCP acknowledgement or in order to reduce TCP-ACK probability of collisions, we implement an additional dedicated link, not a high bitrate link, just a couple of kilobit per second link that directly connect PCA and PCB. So data will be sent through the complicated network, while the TCP acknowledgement is fastened by using dedicated link here. So This proposal is examined by using NS2 simulator by creating 20 nodes here. 20 nodes. We have 20 nodes here that communicating each other by using the setup traffics, either TCP and UDP. So here node 9 send data to node 8, and node 8 by using TCP. Node 8 should reply data by using acknowledgements. In existing method, when data sent from 9 to 8, TCP will replay by sending TCP-ACK through the same network. In the proposed method, we fasten TCP-ACK by using a dedicated link. We can use, for instance, direct connection by phone line or by other means, satellite, for instance, for making direct connections. So if 9 is live camera and 8 is the station receiving the video, direct link, a small bandwidth link will help to fasten transmission by routing the TCP-ACK through this dedicated line. Here we see the routing techniques, which is data flow from the complicated network, and then the TCP-ACK flow. TCP-ACK flows through this dedicated link. So the assumption results consistent TCP delay reduction here, where when complex network TCP and TCP-ACK send by using the same network, it produces delay as in this figure. But when the TCP-ACK is routed into the dedicated link, here TCP transmission is much faster for every bitrate of videos. Shows that the proposed method works as expected. So to conclude, this paper has proposed TCP-ACK collision reduction method to fasten TCP transmission. The mathematical analysis has proven the effectiveness of the proposed method, while the distributed interface space reduction in Wi-Fi network is able to implement the proposed method and proven to have lower delay. Early bandwidth requests also help the method implemented in WiMAX that result also lower delay. In a complicated network, a small capacity of dedicated direct link for TCP-ACK is able to reduce TCP transmission delay significantly. Okay, thank you.